Hello, everyone. Today we will continue with our lecture on data, but we will do something a little bit more interesting. So last time we have seen the SQL, the structured or standard query language that we can send requests to the database, receive response in the form of a report or tuples, so that is rows or objects from the database that satisfy our query. Now, today we will look at analyzing the data a little bit so that we can see what's the purpose of collecting this data and how we can use this data for our advantage. So we have seen types of data that existed, and we mentioned in the data, the objects are the rows and the descriptions of features or properties of these objects are on the columns in the relational database. That is coming in the form of a table. Now, we said that they are objects because they could be customers of a company. They could be patients in a hospital. They could be students in the university. But other than humans, we could have other things such as medical exams. It could be a database of tumors. It could be climate data. It could be a database of particular cities and the climate and how climate was changing there. It could be biological data showing the human genome, or it could be transactional data. So we could have here exams, human genome, we can have transactions. So what are transactions? So transactions is, let's say, when we go to a grocery store and we place in our shopping basket a bunch of items. Say we buy bread, milk, fruits, or other items. Once we check out from the grocery store, the things that we have purchased are recorded in their database as a transaction. So the transaction contains certain items, A, B, C, D. So those items could be things that we purchased from the grocery store. So the transaction like this will be recorded in the database every time we check out, every time we have a new receipt, right? The receipt is showing what we purchased. So the combination of items that we purchased is a transaction that gets recorded into the database. So why is this getting recorded in the database? Because this is important information for the grocery store. we could come back and later and analyze this data. This is called market basket analysis. So the customer buying habits can be studied by finding associations or correlations between the items that the customers place in their shopping basket. So, associations or correlations between the items that we place in our shopping basket. Let's say this person is buying milk, egg, and sugar and bread, and the other one is buying milk, egg, and cereal and bread, and the other one is buying just eggs and sugar. So from here we can see that the eggs and the sugar are in everybody's basket. So this combination of items appears to be a frequent pattern in our data. So we research for frequent patterns. That is transaction that occurs or repeats many times in our database. So what do we mean by it repeats many times? How many times does it repeat here? In here, we have only 3 transactions. So it repeats 3 times. So we could have some sort of a threshold saying that if a pattern or transaction repeats 3 or more times, then it is considered a frequent transaction. And this is also called the support of the transaction. So 3 or 100%. This one is happening 100% of the time. Right? Because it happens every time. And it's happening in all the transactions. Why would we care about something like this? So what do we get from knowing that people frequently purchase eggs and sugar together? Can anybody give an example of what we can do with this information? Why do we think that this information is important? Yes, you can feel free to speak up. Why do you think it's important to know? that these items occur frequently, and what can we do with this information once we know this? Can you give an example of a business or a company that is using these associations of items like this? How about Amazon.com? Do you think Amazon.com is using this technique? What happens in Amazon when we buy something or when we place something in our shopping cart? It's usually showing underneath a bunch of other stuff, right? It says, by the way, you purchased pizza. We also think you might be interested in Coca-Cola because a lot of people buy pizza and Coca-Cola together. Um, and we think that this is so that's a frequent pattern. So if you're buying the pizza, we're going to suggest you to also buy the Coca-Cola because most people would do that. So we think that that's something you'd be interested in. So Amazon will show a bunch of other products the customer might be interested in once they place something in their shopping bag. And believe it or not, those really are important and interesting items to that particular customer. So oftentimes we find ourselves browsing the things Amazon suggested because they are helping us to really find what we're looking for. And they are in fact stuff that we're interested, items or products that we're interested in person. So this is widely used, especially for online retailers, but as well as for online businesses, but as well as for in-person retail stores and grocery stores. So given a database of transactions, where each transaction is a set of items, we would like to find groups of items that are frequently purchased together. So this is our receipts we got from the grocery store. And it lists all those items for us. So this allows us to extract information on our customers' purchasing behavior. This is actionable information because we can use it to our advantage. How can we use it to our advantage? So actionable information means we can take some action based on the information. If, let's say, we find out that in the grocery store, eggs and sugar are frequently purchased together, we could take some action, right? We could put the eggs next to the sugar so that it's easier for people to see them and find them. On the other hand, um, Yeah, so we could use this to rearrange the store. So people are buying more things because once, let's say, if the eggs and sugar are frequently purchased together, placed them next to each other, someone goes to get eggs and he sees the sugar, he's like, oh, I need that too. So they place it in their shopping bag and this time end up buying more things. So this is really helpful for both the business and the customers, because for the business it helps to increase profits, and for the customer it helps them to find exactly what they want. Okay, so for business organizations, increase profits, and for customers, find the products. It's interesting. So, given the database of customer transactions where each transaction is a set of items, we would like to find groups of items that are frequently purchased together. And when we say frequently, like we mentioned earlier, we could establish some threshold. Let's say if the transaction occurs 3 times or 100% of the time, then it's considered frequent. So the goal of market basket analysis is to extract information on the purchasing behavior of the customers and then extract actionable information. This means we can take some action based on the information, knowledge, or wisdom that we discovered from the data. So we could rearrange the store layout. We could know where to put the new products where we that are coming for our business. And we could know which products to give as a promotion to those customers, because we know if people are buying pizza, they buy Coca-Cola. We want, well, let's say Coca-Cola is a new product. We would immediately know that the pizza and the Coca-Cola are good together, or they like each other. If we have to Let's say if the customer was buying pizza but never bought Coca-Cola, we could put this item on promotion because we know he has a high chance of being interested in this item. So we can discover from the data what's called association rules. So what are these association rules? These are rules. That is, they come in a form of if-then statements. Um, if, if we have product A, then we have product B. That is, if we have product A, then we have product B. For example, A implies B, pizza implies Coca-Cola. So this is what a rule looks like. So this kind of rule would express how products or services relate to each other or how they would group together. So this is actionable information. It could allow us to bundle services together or it could help us make a decision to how to give patients appropriate medication. So if a customer purchases 3-week calling, then they also purchase call waiting. So these two services go together. If a patient has high blood sugar level, then the patient likely has the diabetes. So here are some transactions. Okay, so we have all those transactions here. And they are made of items. So they could contain one or more items. So let's say item 1 is the pizza, item 2 is the Coca-Cola, or they could be bread, milk, sugar, and other items. One item means it's a single element, or they only purchase one thing. If they purchase two things, we will have a set of two items, item 1 and item 2. That's called a two-element set. If they purchase 3, then it's a 3-element set. The support, like we said, is how many of those do we have in our database? Is it 3 or 5 or 100, or is it 100% that is the exist in every single transaction? So support is the cardinality of the item set. The number of times the set is recorded in our database. So oftentimes the users would like to find item sets of high support because those are considered frequent. So we would set up some threshold, like we said earlier, so that we know what is considered frequent. So the item set is frequent if its support is bigger than our threshold. Okay. So let's look at this database. And if you can please take 3 minutes and determine what is the support for fruits and cereals item set. Take 5 minutes to think about this question. What is support for fruit and cereals? This means how many times in our database do we have these two items occur together, the fruits and the cereals? Okay, so can anybody answer this question? Looking at the data here, how many times we have fruit and cereals? Anyone? We only have it one time in transaction number 4, right? Fruit cereals? Only one time. Now we have fruits in transaction 1, but no cereals. The same in transaction 2, we have fruits. They purchased vegetables with the fruits and dairy, but not cereals. So really, the fruits and the cereals only occurred one time. So is this item set frequent? Is this item set frequent? Well, we're saying that if it is bigger than the threshold 3, then it's considered frequent. Since our item set only occurred one time, then 1 is less than 3, so it is not frequent. Now, dairy and fruit would be frequent. Well, dairy by itself is frequent because dairy only by itself occurred 3 times in transactions 1, 2, and 3. So does the fruits. They occurred in transaction 1, 2, and 4. Now, dairy and fruit together is occurring 2 times in transaction 1 and 2. So that is not frequent because its support is equal to 2. And we would like it to be 3 or higher to be considered that it's frequent. So this is very simply how we look for frequent item sets. So let's see how this inverse transaction database. So let's see how this algorithm works. There are a number of measures that we can measure in order to determine if the item set that we extracted is interesting or useful. One measure is the support, what we have just seen. How many times the item occurs in our transactional database. If the two items together occur frequently, then it means these items are highly correlated to each other. That is, having the one item present implies that the other item will be present as well. So that's the support, the number of times that it occurs. Now the confidence is something different. It is the support of those two items divided by the support of the item on the left-hand side. So the confidence will tell us how likely is that this rule is true. If we have Coca-Cola, we also have pizza. We have pizza, we also have Coca-Cola. How likely is that to be the case? Is it 60% of the time, 70% of the time, 90% of the time, 100% of the time? So what is our confidence that if we buy pizza, we also buy Coca-Cola? That's what the support is showing. So those two measures we can calculate on every rule to determine if the rule is interesting or useful. So the users would like to find rules of high support and high confidence. So the user is the one who provides threshold. You see, earlier we said the item set is considered frequent if it's bigger than 3. The user is the one who will provide this number. What does it mean to me or to us or to our organization that this set is frequent? How many times it needs to happen for us to consider it to be frequent? So there are two thresholds they will provide, the minimum support and the minimum confidence. We would like to extract rules like this. A implies B or pizza implies Coca-Cola. We would like to extract rules which are with high confidence. So we could provide a threshold for the confidence as well, let's say 75% or 80%. So the rules that we're extracting need to have specific value for the support and the confidence for us to consider them frequent and give this knowledge to the user as some knowledge that was discovered from the database. Let's see very quickly how we're going to extract the frequent item sets or patterns from this transactional database. Here are the transactions ABC, AC, AG, BF. So these things, A, B, C, D, E, F, they are just elements for that particular store. They could be, if it's a grocery store, they could be bread, milk, and honey, or vegetables. And there is a transaction ID. So that's all that goes into the database. And for us to find the frequent patterns there and to take some action to our advantage, we need to we need to check the support and the confidence, and if they are bigger than the given threshold, they're considered frequent. So the minimum support should be 2 or 50%, and the minimum confidence also 50%. This is what the user gave us. So we're going to now extract the frequent item sets from this little database here. So A is happening 3 times, 1, 2, 3 out of 4 transactions. That's why A is happening 75% of the time. B is happening in 2 transactions, 2 out of 4, that's 50%. The same for C, 2 out of 4, 50%. And the same for the set AC. It's occurring 2 times because in the first transaction we have ABC. So we do have AC. In the second transaction we have AC. So this one is happening 2 times out of 4 transactions, 50%. If an item set is not frequent, then any of its subsets are also considered not frequent. We can remove the item sets from our results or from our analysis that are not frequent because we're not interested in them. So let's see, what are the steps of this algorithm? How are we going to? It's called Argval algorithm or a priori algorithm. How are we going to extract the frequent patterns? The first step, so to just extract the frequent patterns and find association rules from the database. The first thing we need to do is start with a single element sets. Single element set means it only has one item. Let's say A, B, C, D. Count the number of times it occurs. If it's bigger than the threshold, then it stays and it's good. If it's smaller than threshold, we would remove it from the analysis. But first we start with a single element set. So the set is considered frequent if the sport is 2. In this example, we start with the database, look for A. A occurs 2 times, the orange one, in transaction 1 and 3. Then we go to the next element, B. B occurs 3 times in the green one, in transaction 2, 3, and 4. So B, the count for B is 3. For C, it's 3 as well. We have to check every single element from data like this. Check A, check B, check C, check D, check E by itself. So those are count 1, it means it's a single element set. Is it frequent? Which ones of these are frequent? The ones that are equal to 2 or more. So then A, B, and C will be frequent, and also E. D is the one that is not frequent, and we will remove it. So what happens is now you see this arrow here, count, it says count 2. So from the single element sets that are frequent, we generate 2 element sets by taking all the possible combinations between them. Let's say A with B, A with C, A with E. Then we take B with C, B with E, and finally C with E. Lift. Okay, so we try to do this. And we end up with a list of 2 items. So this is called a 2-element set. The same thing. We will look for the frequent patterns here. How many times did A and B occur together 1 time? How about A and C 2 times? How about A and E 1 time? So write it down. Minimum threshold is 2. So any of those sets which the sports 2 or higher will remain. And we only have those 4 left here: AC, BC, BE, and CE. These are important. These are the ones that satisfy the threshold. The ones that are less than this are just eliminated, or just they're crossed out so that they're not used. And then we go to 3-element sets. The longer the number of elements are, the less frequent they would occur. the longer the sets get, the less frequent they are. So we have the two element sets that have two elements A and C, B and C, B and E, C and E. There's four of them that are frequent. Now, out of those, we take all the possible combinations and we generate three element sets. So let's say A with C, A with B and C, B with C and E, B with E, and C and E. So out of all those combinations, the only frequent one is the BCE because it happens two times. All the other ones I just mentioned are their count is either 1 or 0, which is less than the threshold. So this algorithm ends here because there is only one set that we get here, BCE. If we had two sets or more, we would continue to combine them to generate four element sets. The algorithm would stop either when there is only one set left, or none of them. But like I said, the longer they are, the more elements they have, the less frequent they become, and eventually the algorithm stops. Do you have any questions about this one? Okay, so this is how we, so once we have found those frequent item sets, we can build rules from them, right? So we could take the set here, B, C, E, and generate rules from this. How we will generate the rules. What rules can we get from this one? So we will get several rules from this one. We can get the rule that B implies C. That's one rule. We can get the rule that B implies E. And we can also get the rule that C implies E. So depending on the support and confidence of these rules, we can say that they're frequent. We can say that they're frequent or not. Let's say support is 80% and confidence is 75%. So these are the rules that we can extract from this DCE item 7. Okay, so that's how we discover the frequent patterns and extract rules from them.